Okay, so as you can see from the lecture slides, we are getting a similar answer. We have put the ones down there. So based on the midterms given, we find out the combinations and we'll get the same answer, as you can see. You can also do that, but as you can see, as I already mentioned, this is going to give you AB prime. Now, when you do that, you're actually getting another input over here. Rather than just having B prime, you have A as well. So that's why we go always for the largest possible combination. Here is another example. So once again, we have to draw three variable K-map with 8 squares. This is A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. Midterm 0, 1, 3, 2, 4, 5, 7, and 6. You have to do practice. Once you start doing a practice, you will learn how easy it is and you will learn how easy you can put those down. All right, so we have got 0, 2, 4, 5, and 6. Interesting. And the rest are zeros. Okay, so the first possible combination, I can see that clearly that I can combine 4 adjacent ones. So by having the sides m0, 2, 4, and 6, and let's see what will be the expression for it. Now, when you look at it, A is changing 0 to 1 on both cases. So we don't write A, we look at B. B is 0, changes to 1 over here. C is 0, stays 0. So that means we can write C prime. Then I put OR because I have got another 1 over here. Again, I can go for that, but that's going to give me a long, larger expression with more literals in there. So it's like A, B prime, C, if I do that. A, B prime, C. But rather than doing that, I can go for a combination of M4 and M5, and this will give me A is valid, it's not changing. B is 0, stays 0. C is 0, changes to 1. So A is staying 1, B is staying 0. So I can just say it's A, B prime. And that's it. This is the solution of it. Yet another example, but this time, rather than having the Boolean function, we have got a truth table, which we can, again, directly map it to the K-map. So 8 possibilities, 8 squares, and we have got ABC again, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, midterm 0, midterm 1, 3, 2, 4, 5, 7, and 6. Okay, so let's check. Midterm 0, it is 0. Midterm 1, it's 1. Midterm 2, 0. Midterm 3, it's 1. Midterm 4, it's 1. Midterm 5, it is 1. Midterm 6, it is 1. And midterm 7 is 0. Okay, so how are we going to do those combinations? We have a couple of alternatives actually over here, which I'm going to do them in a different color. So let's say F. Now, the first combination that I can easily see is M1 and M3. So M1 and M3 is giving us what? A is not changing in both cases. B is 0, changes to 1. C is 1, stays 1. So that means I can just say it's A prime and C. Because C is 1, A is 0, which is stable. This is one of those. Then I can see another one. This is tricky one. M4 and M6. I can combine the sides. This is also valid, as I'm combining two of those together. I cannot have 3 by including 5, as it is not power of 2. So I can have only those two, which is going to give me A is 1, stays 1. B is 0, changes to 1. C is 0, stays 0. So I can say this is A, C prime. Now, this is another one, which is I have got M5. As I already mentioned, rather than having a single combination, which will give us more literals, I can either combine with M4 or with M1. This is totally up to you. When we said at the beginning of the lecture that there is no unique solution, this is what it means. So I'll go for M5 and M1. This is going to give me an expression where A is changing, B is 0, C is 1. So B prime, C. Now, some of the students are what they are doing when they've done this combination, they also go for the other one. So they also do M4 and M5. It's not wrong, okay? You can get an expression A is 1 and B is 0, C is changing, so A, B prime. But when you want to write these expressions, you have to write the ones that you have covered. But if you are covering, for example, M5 twice without any need, you don't write that. That becomes redundant. So this is actually redundant, or maybe this one is redundant based on your choice. So we have to write just one of those. So A prime, C, and AC prime are definitely going to be in there. And from one of those, I'm just going to write B prime C. Or you can write alternatively A prime C or A C prime or AB prime. These are both valid, but not together. Okay, so another example. Given below, K-map, find the minimal product of sum form. Okay, so rather than going for a sum of product, we'll go for product of sum. Now, how do we do product of sum? If you do remember, product of sum is representing zeros in the truth table or in the equation. So we have to look at the zeros rather than ones, max terms, not min terms at this time. This is what is asking to us. So A, B, C. And we have got 1, 1, 1, 0, 0, 0, 0, 0. So if we are going for product of sum, we have to go for the zeros. The first step is find the SOP form for f prime, which is zeros. So I can combine these four, which is obvious. And I know that this is equivalent to A. And then I can combine these two, which is going to give me A is changing, it's B, C prime. So F prime is actually equivalent to A or B, C prime. Now, in order to find the POS equation, as you do remember, we had to take the De Morgan of that equation. So B, C prime, because this is F prime, and we have to take the De Morgan on both sides. So F is going to be, if you take the De Morgan, this becomes A prime, B prime plus C prime. And that will be our result. Same steps, we are getting the same outputs. If you want, you can combine them back in. And you will get similar results. Okay, another example. We have got minterm 5157. Draw the K-map. Okay, so the first step is drawing the K-map. We have got ABC again. And 1, 5, 7, those are the squares. If you want, sorry, that's 0.1. 1 is here, 5 and 7. And the rest are just zeros. And it's asking for a Maxterm expansion. So what is Maxterm expansion? Minterm expansion is given to us, as you can see. The opposite of that is Maxterm expansion. So I can say f a, b, c function, the product of the max terms, what is not included or what is not 1, it's going to be 0 and it has to be max term. So 0, 2, 3, 4, and 6. And those are our max terms. Then step 3, minimal sum of product. Okay, minimal sum of product, we have to combine ones. I can combine these two, which is going to give me A is changing, it's just B prime C. And I can also combine these two, where we have got A, B is changing, but C is 1, so it's AC. So I can say that F is equivalent to B prime C or AC. How about zeros? Because it's asking for minimal product of sum, then I have to combine zeros on both sides. Now A is changing. I have got B is changing. We just have C prime. So this is C prime. And I have one more, which is this one. And that is A is 0. So A prime, and it's B. So now we can write f prime is equals C prime or A prime B. And f prime today to De Morgan, f is going to be C A prime plus B. And that will be the product of sum. Okay, so another property, another example, sorry. Let's have another one over here. But rather than having the min terms or the truth table, we can have A, B, C. I can show you the equation A, B, C prime, or B, C prime, or A prime. Now, when we draw the K-map, we draw based on the expressions. It looks like a tricky one, but it's not actually. So let's start with the first one, where we have got A, B, C prime, where A is 1, B is 1, C is 0. A is 1, B is 1, C is 0. So that means this is the point. Then we look for BC prime. So we don't know what A is going to be, so A has to be in both sides. BC prime, it's also this one. So that means we have to put 1 over there because it also includes where A is 0. And then the last one is A prime. So whatever we have got on this row, they're all going to be 1s. Okay? And the rest are just 0s. Ah, hang on. There's a small mistake over here. A, B, C prime, this is B prime. B prime C. So B prime C is there. This is B prime C because A can be anything, and this is going to be 0. Now, the combination, I can go for this long rectangle, which is A prime, and I can have these two, which is A is changing, it's just B prime C, and I can have these two, which is B C prime. So I can easily write F is A prime or B prime C or B C prime. Now, if you do remember from chapter 2, we have got some conditions like don't cares. They can be either zeros or ones. And when we are doing algebraic manipulation, if we make an assumption that we are going to use it as a 1 or 0, we might end up with a more optimized or more simplified expression. This is also applying for the K-maps as well. So this is the K-map given to us with the don't care conditions. So 0, 0, 0, 1, 1, 1, 1, 0. And this is 0, 1. A, B, C. So 1, don't care, 1, 0. 0, 0, 1, and don't care. Now, either we can use it as a 1 or 0, depending on our needs. So at this point, if you want to combine x with 1 so that you can have a larger rectangle, we can do that. There's no restriction. But I can see this one doesn't need anything. So I can write this as A is changing, it's just BC. And I have got 1 over here. And this one I can combine with x. So it cannot be alone. And I can write this as a prime and b prime. Okay? Because if you think about it, if you just have 1 over there, this is going to be a prime, b prime, c prime. So rather than having 3 literals, I can just have a prime, b prime. Okay, that's why I combined and I made an assumption that x is going to be 1 at that point. Now, this is for SOP. F is going to be a prime, b prime, or bc. For POS, which we need to find out f primes, I can combine that 0 with x. So I'm making assumption that that x equals 0. And this will give us BC prime. And also, I can make a combination of those two, which is going to be A and B prime. So I can write this as A, B prime, or BC prime. And then I have to take the De Morgan again, A, B prime, or BC prime, prime. Then F is going to be A prime plus B, B prime plus C. And that will be the expression for that. So don't cares can be used either as a 1 or a 0, and I can make a largest possible combinations.